Let's practice finding the sum or difference of fractions using the LCM. And specifically, we want to use the least common denominator. We can use the LCM to help us find that. For number 1, we have the fraction 3/4 plus 1/3, but notice we can't add them right away because they have different denominators. They have 4 and 3. So on the side here, we can go ahead and use a method to find out the least common multiple. But if you notice that they have a GCF of 1, so they are relatively prime, that means that they have nothing in common besides 1. And so if you go ahead and look on the outside here, then 1 times 4 times 3 will get us our LCM, and that's going to be 12. So we're going to use LCM or our LCD in this case and say that's going to be 12. That's the first time that 4 and 3 meet. Okay, so I'm going to go ahead and rewrite the fractions here so it's super clear. We have 3/4 plus 1/3. And again, the 3 and 4 don't match right now, so we're going to go ahead and see, okay, 4 times what gets you 12? Looks like 4 times 3, so we're going to multiply by 3 on bottom. Whatever you do to the bottom, you must do to the top. And then for the 3 times what equals 12? 3 times 4. So we're going to go to multiply this 3 by 4, and then if we multiply the bottom by 4, we multiply the top by 4. All right, so on top here, this 3 times 3, that's going to be 9. And then on bottom, this 3 times 4 is definitely going to be 12. And then we're going to go ahead and add the second fraction. This 1 times 4 is going to equal 4. And then on bottom here, this 3 times 4 is going to equal 12. So at this point, you can notice that we do have common denominators. So this one is 12 and this one is 12. That's our LCD that we came up with earlier. And we can go ahead and add these fractions because they have common denominators. So we're just going to go ahead and add this 9 plus 4. 9 plus 4 is 13, so we're going to write 13 over 12, and that's going to be the sum here. To write the final answer, we can either leave it as this 13 over 12 or 13/12, or we can write it as a mixed number, which is going to be 1 and 1/12. Right now, it doesn't really matter which version you use, they're both considered okay. For number 2, we have the fraction 1/8 plus 2/3. Right away, this 8 and 3 have nothing in common and they're different denominators, so we can't just add these right now. So we would like to find out when 3 and 8 meet for the first time. Turns out they are relatively prime, so their GCF is 1, so we're going to put an 8 and a 3 down here, right? And if we go ahead and multiply everything on the outside, this L makes the LCM. That's going to be 1 times 8 times 3, which is 24. Or you can say 8 times 3 is 24, or 8 times 3 is 24. So we found out the LCM, or the LCD in this case, is going to be 24. All right, so let's go ahead and write this out so we can get the equivalent fractions. We have 1/8 plus the 2/3. And how does 8 become 24? Well, 8 times 3 would be 24. Whatever you do on bottom, you do on top. And then 3 times 8 is going to be 24, so multiply by 8 and 8, top and bottom. For the first fraction, 1 times 3 is going to be 3, and then 8 times 3 is 24. So again, this fraction up here is equivalent to 3 over 24. And then we're going to go ahead and add the second fraction, so 2 times 8 is 16, and then 3 times 8 is 24. So this fraction of 2/3 is equivalent or the same thing as 16 out of 24 in terms of their value. All right. Notice now we have 24 as our LCD, and so we have common denominators, so we can add. 3 plus 16 on top is going to be 19, so we have a final fraction of 19/24, and this is a proper fraction, so you can't write it as a mixed number, so that would be our final answer. For number 3, we're going to go ahead and try subtracting, so we have this 4/5 take away 1/3, so 5 and 3, they have different denominators, so we need to find out the first time they meet. So let's go ahead and write 5 and 3 next to each other. And it looks like they have 1 in common, and I think that's it because they are relatively prime, which means we can be as simple as just multiplying 5 times 3 to get us the LCM or LCD. So 1 times 5 times 3, or you can say 5 times 3 and 5 times 3. So we know our LCD here, the first time 5 and 3 meet, are going to be at 15. All right, so just like 1 and 2, let's go ahead and see if this is getting a little bit more familiar now that we've practiced it a couple times. So we need this 5 and 3 to meet at 15. So the third multiple of 5 is 15. So we're going to do times 3 times 3. And the fifth multiple of 3 is going to be 15. So times 5 times 5. 4 times 3 is going to be 12. 5 times 3 is 15. And we're going to take away. And then 1 times 5 is 5. And 3 times 5 is 15. At this point, we have 12 minus 5 on top. So since we have common denominators, we can just subtract. So 12 minus 5 is going to be 7. So our final difference here is going to be 7/15, and that's as far as we can go. 7 and 15 are relatively prime, so we can't simplify, and that's our final answer. For number 4, let's see what fractions we have here. Okay, we have 5, 6, and we have 1/4. So in the first few examples, if you just multiplied the denominators together, you happen to get the LCD, but that's only because the denominators were relatively prime. Okay, so please be careful on this example here. For number 4, we have the numbers 6 and 4, right? 6 and 4 are not relatively prime. So if you just multiplied 6 times 4 together, that's not the LCD. Notice they have a GCF of 2. So we have 3 and we have 2 down here. So if you want to find the LCD, what we must do is we must take a look and multiply these outside numbers to get the L. 2 times 3 is 6, 6 times 2 is 12, or you can say 4 times 3 is 12, or 6 times 2 is 12. So we're going to go ahead and say that the LCD, or the first time 6 and 4 meet, are going to be at 12. Okay? And again, you could also multiply 6 times 4 to get 24, and divide by the GCF of 2 to get 12 as well. Okay? So how do we get these new fractions? Let's take the 5/6, and let's take away the 1/4. Notice I'm leaving a little bit of space because I can write my work in there. So how many multiples do we need of 6 to get to 12? So it's going to be times 2 times 2. Okay, and notice that's what we used over here. That's 6 times 2. And then what about 4? Well, 4, it's the third multiple, so it's times 3 times 3. And you can see that over here, 4 times 3 is going to be 12. Okay, so let's look at 5, 6 first. So 5 times 2 is going to be 10. 6 times 2 is going to be 12. For the second fraction, 1 times 3 is 3. Then 4 times 3 is 12. So at this point, we have common denominators, which means we are allowed to add or subtract. So 10 minus 3 is going to be 7. And then keep the same denominator as 12. So 7/12 is the most simplified version for the difference of 5, 6, and 1/4. For number 5, we have the fractions 8/9 take away 1/6. So we would like to subtract these fractions, but they are different sized pieces. 9 and 6 are not the same denominator, so we can't just go ahead and do that from the beginning. So let's go ahead and take 9 and 6 and write them next to each other. We're going to go ahead and find when they meet for the first time. It looks like 3 is a common factor. So 3 and 2 are left over, and I think 3 and 2 are relatively prime, so we're going to stop there. If we go ahead and multiply these outside numbers, 3 times 3 is 9, 9 times 2 is 18. So the first time that 9 and 6 meet is going to be 18. Again, if you just multiplied 9 times 6, that's 54. They do meet at 54, but that's not the first time they meet. All right, so we're going to try to use the LCD. So let's take this 8/9 and then take away the 1/6, but let's go ahead and try to rewrite these fractions with the same denominator. So notice how many 9s do we need to get to 18? Well, it looks like 2 of them, right? 9 times 2 would be 18, so let's go ahead and do times 2, top and bottom. And then how many 6s do we need to get to 18? Well, it's going to be 3. Look at those diagonals. So 6 times 3, 1 times 3. And so on top here for the first fraction, 8 times 2 would be 16. And on bottom, 9 times 2 is 18. And for the second fraction, 1 times 3 is 3 on top, and then 6 times 3 is 18. So we have 6 18ths take away 3 18ths. Now that we have common denominators, which is the least common denominator, or LCD, we can subtract. 16 minus 3 is going to be 13. So we have 13 over 18. You should check to simplify this fraction. However, 13 is prime, and it does not go into 18. So 13 and 18 are relatively prime. It can't be simplified. For number 6, we have 9/10 plus 5/5 here. Okay, it's kind of interesting. 5/5 is just a whole, so hopefully the answer will make sense, but let's go ahead and practice finding the LCD here. So for 10 and 5, so we have 10 and 5, and we're wondering when do they meet for the first time. If you put a 5 as a common factor, 5 times 2 is 10, 5 times 1 is 5. Then you can go ahead and see if you multiply these outer numbers, 5 times 2 is 10, 10 times 1 is still 10. Or you can say 5 times 2 is 10, or 10 times 1 is 10. So stating the LCD here is just going to be 10. All right, so if you go ahead and write out your work for this, we can go ahead and say 9/10, and then leave some space, and then 5/5. Okay, to get 10, well, for the 10, you could actually leave it alone, but I'm just going to write in the work here so you can see it's super consistent. And then for the 5 has to multiply by 2, so times 2 times 2. The first fraction is definitely going to stay the same here. 9/10 stays as 9/10. And then for the second fraction, 5 times 2 is 10, so 10 out of 10 is still a 5 out of 5 in terms of the value of it. Notice that we have a common denominator of 10, so 9 plus 10 on top is going to be 19. So you can either leave your answer as an improper fraction like this, or as a mixed number, it's going to be 1 and 9/10. These are both the correct values for the sum of these fractions. Cool, all done. All right, for number 7, we got some bigger denominators here. We have 5/18 plus 7/24. So these denominators are a little bit bigger. Now let's see, when do 18 and 24 meet for the first time? We could multiply 18 by 24 to figure out a time they meet, but that's not going to be the first time they meet, okay? I'm going to start with maybe just a 6 on the side, because I know 6 times 3 is 18, and I know 6 times 4 is 24. I think 3 and 4 are relatively prime, so we're going to stop there. The 6 times 3 times 4 would get us our LCD. If you don't want to multiply those three numbers together, you have a few options. So again, you can multiply 6 times the 3 times the 4, or you can multiply 24 times 3 or 18 times 4. All of them are going to get you the LCD. So I'm going to go ahead and write the LCD equals. And I think the easiest one for me to use is probably just this 24 times 3. So if you do 24 times 3, you can see that's going to be 72, right? So just writing that out so you can see that's 72. That's the first time these numbers meet. So let's go ahead and write this down. This is going to be 5/18, leave a little space for the work, plus 7/24. All right, so how many 18s become 72? It looks like 4 of them, so we're going to have to multiply times 4 times 4. And then how many of these 24s become 72? So it looks like there's 3 of them. So we're going to do times 3 times 3. All right, so for the first fraction, 5 times 4 is going to be 20. It's going to be 20 over 72. And then plus the second one is 7 times 3, so that's going to be 21. So we have 21 over 72. All right, cool. So 72 was the first time they were going to meet, so we were able to make both fractions over 72. And then we can just add them. So 20 plus 21 happens to be 41. That's a prime number over 72. And 41 is not a factor of 72. So 41 and 72 are relatively prime, so we cannot simplify this fraction. For number 8, we have 11/12 take away 5/9. So our two denominators are 12 and 9. So just identify those first. So let's take this 12 and put this 9. And let's see the first time 12 and 9 meet. Let's put 3 as a GCF. That's going to be 4 and 3 on the leftovers. They're relatively prime, so we can go ahead and multiply 3 times 4 times 3, and that'll get us the first time they meet. Or you can say 9 times 4 is 36, or 12 times 3 is also 36. So the LCD, or the first time 12 and 9 meet, is going to be at 36. All right, so let's go ahead and use that information here. Now to get 36, what does 12 need? We need 3 12s, or 3 multiples of 12 here. So we're going to do times 3 times 3. And then for the 9, what does a 9 need? Well, 9 times 4 is 36, so we need 4 of these 9s to get to 36. New fractions are going to be 11 times 3 is 33 over 36. And 5 times 4 is going to be 20, so it's going to be 20 over 36. We do have common denominators, so we can go ahead and subtract. 33 minus 20 is going to be 13. So we're going to have 13 over 36 for our difference. For number 9, we have 7/15 plus 5/6. So let's go ahead and see. We can't add these right now because they have different denominators. So let's go ahead and take care of that. 15 and 6 looks like 3 is a common factor. 3 times 5 is 15. 3 times 2 is 6. 5 and 2 are both prime numbers, so they're relatively prime as well. And then so we can go ahead and multiply 3 times 5 is 15. 15 times 2 is 30. Or you can say 5 times 6 is 30, or 15 times 2 is 30. So no matter how you look at it here, the LCD, the first time 15 and 6 meet, is going to be at 30. So let's go ahead and rewrite these. All right, so how many 15s do we need to get to 30? It looks like it's 2. So let's go ahead and write times 2 times 2. And how many 6s do we need to get to 30? It looks like it's 5. So let's go and do times 5 times 5. 7 times 2 is going to be 14. 15 times 2 is going to be 30. So we have 14 30ths plus, and then 5 times 5 is 25. So we're going to have 25 over 30. And at this point, we have common denominators, so we have 30 and 30. So we can add 14 plus 25. 14 plus 25 should be 39. So we have 39 over 30. All right, so this is the first problem where we have to do a little bit more work because I'm noticing something right away. If you take a look at this 39 and 30, they're actually not relatively prime. They have a GCF, so think about your divisibility rules. So if you're wondering if you can simplify or SimpLEEfy this, right? You do have two options at this point. One option, I'll go ahead and write it a little bit farther below here, is take 39 and 30, and you can go ahead and see what their GCF here is. So again, 39 over 30, if we're going to simplify fractions, we can use the ladder method as well. Using your divisibility rules, 3 times 13 is 39, and then 3 times 10 is 30. So that must mean that their GCF was 3, so that wasn't 1, right? And you could divide by it. So you can go ahead and divide by 3 and divide by 3, and you would realize that to write a more simplified answer, you should write 13 tenths. Or as a mixed number, if you wanted to, you could write 1 and 3 tenths. So these would be the final answers here, right? Remember, to be fully simplified, you must have the numbers be relatively prime to each other. So if you have 39 over 30, they have a GCF of 3, you should divide it by 3, okay? If you preferred, however, to use prime factorizations, you could have taken the 39 over 30, right? And if you like prime factorizations, that 39 is 3 times 13, and then that 30 on bottom is 2 times 5 times 3, right? So you can go ahead and see what would cancel out here, and you can see that the 3's would cancel out, and then so on top you just have 13, and then on bottom 2 times 5 is 10. So if you prefer prime factorizations, you can use that. If you like the ladder method, that's also perfectly fine. But just always check and see if you can simplify your fractions, making sure that the numerator and denominator are relatively prime. 1 through 8 were all relatively prime when we subtracted or added, so we didn't have to worry about it. But this one we had to check, so please be careful with these types, okay? Number 10. Let's see, we have 17 20ths, take away 5 15ths. We have different denominators, so let's go ahead and try to make them the same by finding out the first time they meet. So 20 and 15, I'm thinking 5 for the GCF, or we have a 4 and a 3. Okay, so it's definitely the GCF, we can't go any further. So on the side here, 5 times 4 is 20, 20 times 3 is going to be 60. So that's 60, or 15 times 4 is 60, or 20 times 3 is 60. So the first time 20 and 15 meet, the LCD is going to be 60. Okay, so let's go ahead and rewrite the fractions. So how many 20s become 60? Looks like it's 3. Don't do any more work. We already have it on the side, so times 3 times 3. And then how many 15s become 60? It's 4. So it's going to do times 4 times 4. Okay, so on top here, 17 times 3, if you need to write it out, feel free to do so. That's going to be 51. And on bottom, 20 times 3 is 60. And for the second fraction, 5 times 4 is going to be 20, and then 15 times 4 is 60. So at this point, we do have the least common denominator of 60, so we can subtract 51 minus 20, that should just be 31. So we should have 31 over 60, and 31 is a prime number, and it's not a factor of 60, so 31 and 60 are relatively prime. This fraction cannot be simplified. For number 11, we have 7 16ths plus 11 12ths. Okay, so we have different denominators, but we'd like to make them the same. And let's go ahead and take 16 and 12 and do this together. So we have 16 and 12. What do they have in common here? Well, I think we can do a 4. 4 times 4 is 16, and 4 times 3 is 12. And then we can multiply these outside numbers to get the LCM or LCD. So 4 times 4 is 16, 16 times 3, that's 48. Or you can say 12 times 4 is 48, or 16 times 3 is 48. No matter how you do it, the LCM or the LCD in this case is going to be 48. So let's go ahead and rewrite the fractions. So how many 16s get you 48? Looks like 3 of them is going to get us 48, 3 times 16. So let's go ahead and say 16 times 3 and do 7 times 3 on top. And then for 12, looks like we need 4 12s to get to that 48. So let's multiply this by 4, multiply this by 4. On top, 7 times 3 is 21. On bottom, it should be 48. On the second fraction, 11 times 4 is 44. 12 times 4 is 48. Now that we have common denominators, we can go ahead and add these fractions together. So 21 plus 44 should be 65, I believe, over 48. Now at this point, we should maybe check to see if we can simplify this a little bit, but if you go ahead and let me just show you, 65 can divide by 5, it's 5 by 13, and I don't think either of those numbers are factors of 48, right? So 48 becomes 2 times 2 times 2 times 2 times 3, and notice they have no common factors, so that means they are relatively prime. Okay, so in this case, I know that we cannot simplify, and hopefully that clears it up for you too. This is an improper fraction, so you can write it as a mixed number as well. So how many times does 48 go into 65? It's going to go in one time. With how much left over, I think it's going to be 17. So it's 17 over 48. Either one of these answers is technically the correct value, so you would be fine either way, especially since this is not a word problem. All right, final problem for these set of practice problems here. We have 19 14ths take away 5 21sts, so we would like the denominators to be the same. Let's take the 14 and the 21 and see when the first time they meet is. And so it looks like 7 goes into both. 7 times 2 is 14, 7 times 3 is 21. 2 and 3 are relatively prime, so we're just going to stop there. 7 times, let's go the other way actually. 2 times 3 is going to be 6, 6 times 7 is 42. Or you can say 21 times 2 is 42, or 14 times 3 is 42. No matter how you do it, the first time they meet is going to be at 42. Okay, let's go ahead and rewrite the fractions. Okay, so how many 14s do we need to make 42? Looks like it's 3. So let's go ahead and multiply by 3, top and bottom. And how many 21s do we need? Looks like 2. So let's go ahead and do times 2 times 2. For 19 times 3, if you need to write that out, I totally understand, but I think that's going to be 57. 14 times 3 is 42. So 57 over 42, take away. 5 times 2 is 10, so it's 10 over 42. And if you go ahead and subtract, we now have common denominator, so we're allowed to do so. 57 minus 10 is going to be 47. 47 is a prime number, and put that over 42. Right, so 42 doesn't go into 47, it can't because 47 is bigger and it's the prime number. So this would be our final answer because 47 and 42 are relatively prime. But if you want to write a mixed number, you can write 1 and 5 40-seconds. And 5 and 42 are also relatively prime, so we're going to stop right there. All right, so these versions are both acceptable for a final answer. So there you have 12 different practice problems on adding and subtracting fractions, applying your understanding of using the LCM as an LCD, and making sure that you have common denominators, specifically the least common denominator, before you add or subtract. If you found this video helpful, please consider giving it a thumbs up, and as always, keep up the great work, and I'll see you in the next one.